Welcome to Maths Weekly. Today we will be looking at binomial expansion where the power is a positive finite integer. If we take this expression as an example of something that we want to expand, 1 plus x over 4 to the power 8, we'll quickly realize that opening up and multiplying out the brackets may not be the most efficient method of expanding it. So there must be another method. Using the binomial series is something that could help us out. So what is a binomial expression? A binomial expression is an algebraic expression of the sum or the difference of two terms. This series is used to expand expressions in the form a plus b to the n and 1 plus x to the n, just like our example 1 plus x over 4 to the power 8. If we were to expand 1 plus x to the power n using the method in the first line, we would get this by substituting in 1 for a and x for b. At first glance, the result may look different from the method shown in the second line, but they're actually the same. For example, if we look at this term and this term, the similarity may not be apparent, but if we have an appreciation for what they both mean mathematically, we will have a better understanding of the similarity. So why is this equal to this? N choose 2 is n factorial divided by 2 factorial times n minus 2 factorial, and this relationship is actually shown up here. So if we were to write out n factorial, we'd get this. And if you write this out, you realize that this part is actually n minus 2 factorial. So you can simplify it out and you get this. And there you have it. N times n minus 1 divided by 2 factorial. Now that we know what the binomial series is all about, let's get back to our first question. How can we expand this? We already know that this method of multiplying out takes up too much time. So let's use the form of the binomial series that uses combinations. And here we have a formula written out. Sub in 1 for a, x over 4 for b, and 8 for n. Sub in all other values and write out your expression, and use your calculator to get the values of the coefficients. 8 choose 0 and 8 choose 8 are both equal to 1, so they do not appear in the formula, the same way that 8 over 4 to the power 0 and 1 to the power 0 do not appear in the formula. Here I have written out the first 4 and the last term of the expansion. This is a question from a past C2 exam paper asking us to find the first 3 terms in ascending powers of x of the binomial expansion of 3 minus 2x to the power 5, giving each term in its simplest form for 4 marks. Using the form of the binomial expansion that uses combinations, we sub in 3 for a, negative 2x for b, and 5 for n. The first b mark was given for arriving at 243. The second b mark was given for getting negative 810x, and there was a method mark given for doing this. And the final A1 mark was given for a complete correct answer only. We've looked at the first form, now let's take a look at the second. Using this route is pretty straightforward for expressions already in this form. Simply sub in your values as I've done here and calculate to get your answer. In order to use this here, we have to change the form of our expression. We do this by factorizing out the 3 and we get this. We can now use our formula and multiply everything by 243 to get our final answer. I hope that you found that helpful. Come back next week for the second part on binomial expansion.